Hello, welcome back. We're working on the concept of the remainder theorem. In the last lesson, we introduced the remainder theorem. We discussed why it works, and we most importantly did a couple of quick examples to show how it works so that you can get some practice. Now we're going to work some more problems, a little more complexity, but really the process is the same. So once you understand the general concept, all of these problems become the same thing. So what we want to do is use this remainder theorem to find the following. We're first going to define some polynomial, p of x, and that's going to be given to you as 1 minus 7x minus 4x squared plus x cubed. And I want you to find out, or tell me, I want you to find the value p evaluated at 6, right? Find p evaluated at 6. So obviously we can do that by taking the number 6 and putting it into each place for x, and then calculating the exponents and all that stuff. But the remainder theorem allows us to calculate it without having to do all of those exponents. In order to use the remainder theorem, what we do is we take our polynomial, we divide it by x minus 6. See, we have to choose it carefully. We don't just divide by something randomly, we divide by x minus 6. And whatever remainder we get at the end of that actually equals the value of this polynomial evaluated at 6. If you haven't watched the previous lesson, then you're going to miss out on why that works. So in the previous lesson, we've already talked about exactly why it works. Now let's go off and figure out how to do it and just get some practice. So basically, to figure out what p evaluated at x is equal to 6 is, we want to find the remainder when we evaluate this polynomial when we divide it by x minus 6. So we take the polynomial, we divide it by x minus whatever we're evaluating at, and whatever the remainder turns out to be, that's what p of 6 is, p evaluated at 6 is. Now the problem that we have here is that this polynomial is all written backwards because remember when we do division, we have to have descending powers of x. So let's go take a second to rewrite p of x as x cubed minus the 4x squared. We're just writing this term next, then this one, minus 7x, plus the 1, because 1 is positive here. So we have a cube, a square, a first power, and then a no power, so we don't have any missing terms, and now that we have it in descending order, we can do this division. So of course, you could do the long division, right? You could say this thing, put a house over it, divided by x minus 6. And you could do the long division, but we've already figured out that synthetic division is much faster. So most of the time we'll just do that. So to do the synthetic division, we take the coefficients. The 1 for the x cubed, the negative 4 for the x squared, the negative 7 for the x term, and then the 1. We draw our house underneath, and then we have to write some number out here. Now we're dividing by x minus 6. In order to do synthetic division, we